5, 4, 3, 2, 1. Hello and welcome to this, the third of the University of Derby student lecture series. We'll be recording today's event so that colleagues can look at this later on, or it can be shared more widely. If anyone has any questions, comments or observations, then please put them into the chat and we'll pick these up at the end of today's lecture. I am Dr. Chris Bussell. I'm the Pro Vice Chancellor and Dean for the College of Science Engineering, and it's a pleasure to host Patrick Kniveton as today's speaker. Just a brief introduction to Patrick. Patrick is a Royal Academy Engineering Visiting Professor at the University of Derby, and he is also currently working on developing a new model for placing students into SMEs, which are the growth engine for the UK economy, as Patrick will outline later. Patrick was a board trustee and vice chair of the Science Council for 3 years until last year. He continues to serve on their Finance and Audit and Risk Committee. Patrick worked for Rolls-Royce for 27 years, patenting the electronic sign technology used on UK motorways. He designed systems for Sizewell B and was head of business management in gas turbine engineering and was head of the engineering skills in the Rolls-Royce nuclear before retiring in 2016. He ran a special initiative with the skills for 50 women scientists and engineers to increase their profile, and one of Rolls-Royce's Women's Network Steering Group members. Prior to Rolls-Royce, Patrick led the challenging installation of the Isaac Newton telescope in La Palma in the Canary Islands. He became president of the Institute for Mechanical Engineering in 2013 to 2014 after volunteering and being a trustee for more than 20 years. Patrick is also a member of their new finance board. Listed in the Derbert's 500 as one of the most 20 influential people in engineering 3 years on the run, Patrick is one of the very first chartered managers with the Chartered Managers Institute and became a champion of the CMI recently. Patrick has always been a strong proponent of coaching style of leadership and confesses he was doing this long before it became fashionable, and loves helping people to develop at every stage of their careers. Patrick is currently working within the College of Science and Engineering to develop our entrepreneurial skills within our students. He is a highly respected international engineer in the science skills sector, taking part in Universe of Engineering updates, the Perkins Task Groups, DSFE skills for defence industry, the NSAN Nuclear Advisory Board, and the UK Defence Enterprise Groups. Believe it or not, in his spare time, because he does have some, Patrick enjoys history, theatre, politics and many sports, including swimming, badminton, walking, cycling, and is now trying golf. Patrick is a proponent of lifelong learning, and I very much welcome his presentation and lecture for us this afternoon. Patrick, over to you.
Good afternoon, everybody. Well, thank you for that introduction, Chris. And on my starting slide, I think the creation, you can see the creative part of the sector is going from a very hairy 19-year-old who wanted to be Jimmy Page of Led Zeppelin to somebody who got invited to number 10 to speak about the national skills in nuclear in 2013. So that was really the height of my career. Today, I want to speak about opportunities that are right here and now in this area of the East Midlands and to the future. I also want to tell you about how we should learn from the past, and there's some great history there, so you'll see lots of grey, very old-looking Greek people, and you'll see some observations from my career and looking ahead, Almost finally, what you might expect to do with your degree, and that applies to all people, whether you're scientists, engineers, or any type of degree in the future. And finally, some aspirational points which I hope you'll find interesting, both from my career and from other people's perspectives. Now, of course, one of the things we all need is a quiz to start with. So let's have a quiz for you. Now, please, I implore you, do not Google. This is just things I'd like you to guess before you see them on the screen. So the first one, how many businesses do you think there are in the UK today? When did the world's first railway run? I'll let you go off with the century. And which famous philosopher will I unlikely quote last? Okay, there's the quiz. So we're going to look at the importance of history looking to the future. So let's start with this rather elderly gentleman. And this is Mr. Pythagoras. Now, very important about his discoveries, look at the shape of his nose. It's a right angle triangle, and that led to his discovery. Of course, he wanted to know why his nose was that shape. And you all know, I'm sure you all know Pythagoras's theorem. What it led to ultimately was, and it's one of the key bases, to fractals. And you see what's called the Pythagoras tree on the right, which is comprised of fractals. And fractals in nature lead us to understand the structure of snowflakes, lightning, biological systems, among others. But in the current day, they've led us to understand and be able to do computer-generated graphics on all those films, urban growth and how that happens, design of heat exchangers, and even signal compression, to name but a few. So that's history and looking to the future. So let's look to today. Today is a time and place of opportunity. Here's the agenda for you. And question one, I asked you, how many businesses are there in the UK today? Well, you may be surprised. You may, in most cases, have underestimated it. There are 5.7 million businesses in the UK in January 18. But 99.9% of those are small and medium enterprises. That's up to 250 employees. They have 60% of the private sector jobs in the UK today. And professional and scientific services are 15% of all UK businesses. This is more surprising. The UK has 6,700 large manufacturing businesses and companies, but 264,000 manufacturing SMEs, 264,000. And if we bring it to the East Midlands alone, there are 370,000 businesses in the East Midlands, a turnover about 231 billion, which is about a tenth of the UK's economy. 75% of those are one person, but a quarter, that's 94,000 businesses, are up to 250 employees. And only 0.1% are bigger than that, just 370 businesses. But, of course, graduates mainly apply to the big companies and the big organisations. We don't hear about the smaller ones. So I'm sure if I ask you, you could name some technical leaders in this region, but I bet they're not these. The first one, I bet you haven't heard of most of these. They're in this region close to Derby. Gibson Technology. They're based at Repton, less than 10 miles away, and they provide the powertrains for Le Mans 24-hour. Sorry, I was distracted. There was a message. Just bear with me a second. Let's get that off my screen. Yes. They provide the powertrains for Le Mans 24-hour races, so high technology in our area. Or have you heard of Clayton Equipment? They're currently building specialist mining engines and locomotives for mine equipments all around the world, and this for Sellafield. They're moving to more green technology, hybrid technology, less than 10 miles away in Burton. Another one just at Swadlincote is Midland Lead, who go from one extreme of providing lead for church roofs and chimney flashings, all the way through to specialist medical lead, and very high quality reactor shielding. It has to be exactly the right proportions. And 20% of their output goes for export. They're just in swaddling code. Or have you heard of Medstrom, who make specialist beds for hospitals, very much in demand at the moment, the low bariatric pressure, so they avoid bed sores and those sorts of things. They're just at Castle Donington, near East Midlands Airport, less than 10 miles away again. You may have heard of this next one, Valent. They're a boiler manufacturing company, gas boilers. They produce some of the first combis and condensing boilers, but they're now moving into ground source and air source greener heat pumps, which we'll see very much more of, and they're just up at Belper. Or maybe you've heard of Frenga Systems. They're just across at Pride Park, again just a matter of miles from the Derby campuses. They do everything from multi-service chilled beams for buildings to radiant panel heaters, and they're just, as I say, in Pride Park, all of them working in high-tech industries. How about Technolog? They're just up at Wirksworth. They produce water and gas industry data loggers and the software and equipment and mapping to go with those. All great opportunities in these companies. What about Lubrizol? Now, you may not be aware of Lubrizol, but I bet most of you who have a vehicle will have used Lubrizol. They produce specialist additives that go in the oils in your vehicles, and it's largely those that have led to typically 4% reduction in emissions or in improved fuel consumption, much cleaner engines, and they're the ones who have led to your oil only needing changing perhaps every 15 or 20,000 miles in some cases, rather than where it used to be 3,000 miles. They're moving to support the electric and biofuel industries as we speak. They're just up in Duffield. And then I want to finish this little one with an absolutely amazing company called Shorescreen Diagnostics, just up at Morley, again less than 10 miles away. They have just received an order for 20 million antigen test kits for COVID-19. They're taking on, or have taken on, 200 extra employees at the moment to develop these test kits for asymptomatic COVID testing. They're world leading in diagnostics, even to the extent of finding out if pigeons in homing pigeon clubs are cheating. Now, can you believe that? But that's the sort of work they do. They're phenomenal. Science on our doorstep. Now, we're going through a time of change, and probably many of you are worried about COVID-19, Brexit, all the other things, the changes in the world that are going on, and how this will affect your futures. Well, I would say don't worry, because change means opportunity in every case. Even more opportunity, arguably, with the changes in our society. And here's some examples. So the CBI estimates that strengthening supply chains in the UK could add 30 billion to the UK economy in the next few years. Many British SMEs in the supply chain still don't use the latest technological know-how, but you guys are training right now to get that latest technological know-how. And remember, SMEs make up the vast majority of all manufacturing businesses in the UK. With Brexit, and I heard this from Marketing Derby, just in a session I was with them just recently, fantastic opportunities are coming from negotiated new trade deals. CPTPP, which is the Southern Pacific region, could be 13% of trade. There are new deals just being negotiated as we speak for trade with Brazil, with India, with the United States, all of which are very high growth areas. More opportunities. And foreign direct investment from Europe and elsewhere is staying high. In fact, there have been some inquiries from Africa recently, a continent that's not shown this interest for decades, to be quite honest. Manufacturing is reshoring its supply lines into the UK. The COVID has particularly put those lines at risk, so there are more opportunities, which means more small suppliers feeding into the larger companies. And construction is going at pace, as I'll show you a bit later. So there's going to be more opportunities for UK labour in the design and the hard work at the shop floor level in construction. And you'll have all heard of the new pharmaceutical capacity that's being built in the UK. So let's move to history, because I hated history at school. I did worst of anything in all my subjects at O-levels. They preceded GCSEs. Now I read and watch it at every opportunity because we learn from history. Some unkind people might say I am history, and that's up to them, and I won't take it too badly, I promise. So what was the very first science lesson? Perhaps the first scientist was this chap, Aristotle, 2,300 years ago. And he said it's the mark of an educated mind to be able to entertain a thought without accepting it. So what he was saying was to challenge, to dream, to think differently. And my view is, unless you do those, even today, you are not a true scientist or engineer. Always challenge, never accept anybody who says the science is settled. After all, the science was settled when we were a flat Earth. That's an organisation which I understand has held its first real global meeting. Think about it. Now, here is a picture of 1900 years ago. This was a large financial centre in Northern Europe. It had pumped water supplies, central heating systems, it had theatre, it had very respected international legal and commercial processes. It controlled natural resources, it invested in engineering, and incidentally it threw people to the lions. That was Roman London around 100 AD. Here's the same scene today, a large, arguably the largest financial centre in Northern Europe. It has water supplies, it has central heating, it has theatre, it's a major centre, it has respected legal and commercial processes. It controls and develops and invests in natural resources and engineering. Thankfully, we don't throw people to the lions anymore. But that's Roman London, and it's there for a reason, and it's why London is a really important centre. And I think the Roman science and engineering was fantastic. Here's some examples of it: the Pont du Gard, an aqueduct. The Romans knew that you had to have gradients around 1 in 1500 to make water flow, and they developed these over miles, tens of miles, to happen. They had a crane, that's the polyspastos, which I thought, I must admit, was a weapon of war, but it's not, it's a crane. So they were used to build things, all the Roman buildings, whether it was the Colosseum or whether it was the aqueducts. Very brilliant in its operation, apart from the power system. They didn't have steam power, they didn't have water power or electricity, so they used humans in that treadmill, which is a bit unkind and a bit tiring, but it worked. In the Roman baths, we just take it for granted, there they were at Bath, but they had lead pipes, they had taps that don't look unlike those we have today. Most significantly, they had waterproof concrete, known as opus signinum, which was probably their most important invention and allowed them to build all these things. And here was one of their most major buildings. It's lasted 2,000 years, it's there today. It was built in 126 AD by the Emperor Hadrian, he of the Wall. It's lasted 2,000 years, and it is the largest self-supporting, unreinforced concrete dome to this day. It's a fantastic achievement. That diameter is about 43 meters. I encourage you, if you go to Rome, go and have a look at this building. It's magnificent. What a structure. Now, however, much as I think the Romans are fantastic, they didn't challenge enough. Why do I say this? So question 2 for you was, when was the first railway? Now, I'm guessing that you probably said round about the 1700s, maybe the 1600s, maybe the 1800s in the UK. Well, you're wrong, I'm afraid, because the first railway is considered to be this. It's in the Diolkos near Corinth in the Peloponnese in Greece. And that was built around 600 BC. This is what's there today. It was used to move boats and ships across the peninsula from one side to the other to deal with invaders or attackers. So there was a railway, 600 years. That's well into the Roman Empire. And several hundred years later, Hero of Alexandria developed the first steam engine. This is what it looked like. There's Hero. Not an up-to-date photo, I'm afraid. Notice how they all look a bit grey and have beards. The fashion's back in. And I don't know whether you can see this now, but I have this wonderful little model of Hero's steam engine. If I had a little bit more time, I'd fire it up and show you it. It's driven by a little burner that sits underneath, but it takes about 2.5 minutes to set up and go, and then it spins very fast. So sorry I can't show you it, but you can perhaps see it rotating. Fantastic little model. So the Romans had steam engines, and they used forms of this power to open temple doors, and they had railways. Imagine if they'd put the two together. We would have had steam railways, ultimately, who knows, electric railways, 1600 years before we actually had them. So today, we may have had railways all around the world, and we'd all be speaking Latin. I don't know about you, I did Latin at school, and I can't remember a word of it. Let's come a little bit more up to date. George Stephenson, he was a railway man with his son, Robert Stephenson. They developed the famous rocket engine. And he was very local, he to the northeast of England, but he moved to Derbyshire in time, and he built railways all around the country. And one of the famous ones was the Derby to Birmingham Railway, which we can still use today, going through Burton, Tamworth. It was built to join with his London to Birmingham Railway, and the junction with the London to Birmingham Railway took it in to Curzon Street Station, which today, if you go into Birmingham, you'll see Curzon Street as a building site. Yes, it's a building site. So it's a building site for HS2. So what goes around comes around. He must have selected a very good site for the terminus of his railway there. He looked ahead, did George Stephenson, and he built railways in an enterprising way, and those railways have already lasted about 170 years, and who would expect them to last at least 250 or more, maybe centuries. So look back, look ahead. This is the time for looking up and looking out, for taking note of history and looking to the future. When I was doing my degree, and I have to give you a little, I confess to something here, I started doing a physics degree at Imperial College in London, and I failed the first year. Yeah, I failed the first year, sadly. But I realised it was because, although I'd been good at physics at school, I wanted to do, I was becoming really interested more and more in engineering, and that was the practical side. So I moved to Leeds University and did mechanical engineering. And I asked, one of the questions was, what bits of my degree will I use? When will I use them? I was a bit worried, all the things I was going to do. Can I remember it all? Well, let me show you how my career developed. And I have to say, I didn't have a plan for this. It happened through various things. I faced redundancy several times, but that led to opportunities. So this is my career in pictures. I started in the bottom left at Railrolls. They made electrical switchgear for power stations. From there, I was made redundant from that, but I moved to a different part of the group to put telescopes on mountains, like Chris has mentioned at the beginning. And this was the Isaac Newton telescope in La Palma, which is just being reconfigured as we speak to search for extraterrestrial life supporting planets all around the universe, using artificial intelligence some 40 years on. Fantastic time, and I wish I had time to show you a video of the drive up to the mountain. It took 1.5 hours every day to drive up a rough track. It wasn't a made-up road, it had no crash barriers, and there was an 8,000 feet drop down to the side. Now at 27, I was happy doing that. Today, I don't think I could hack that. From there, I moved to SKF in the bottom right, selling factory automation equipment, and that was a job, I have to say, I didn't particularly enjoy, and I couldn't get out of it quick enough. I didn't adapt to sales, but that gave me the skills, the commercial skills and the outlook for customers that shaped the whole of the rest of my career. So that'll lead me to one of the reflections which I'll tell you about later on. From there, I moved to rotor wing fans, that's the top left, where we designed, I was engineering manager for design of air conditioning systems on a one-off basis for special buildings in London. That's one for a swimming pool, for very difficult installations in shopping centres. And that was just 30 people, so I learned all about SMEs, and they're fantastic places to work. From there, I moved to Rolls-Royce, or actually it was called NEI at the time, but that was taken over by Rolls-Royce 2 weeks after I joined them. First of all, to work on Sizewell B nuclear power station on pipe stress analysis and instrumentation design. Then another part of that company was doing electronic motorway signs, and it was part of the business that wasn't doing very well, and it was going to be closed until I and the business manager decided we were going to produce and find a way of doing the world's best sign technology. And it led to this. If you can see that, all we used was new geometry on the signs to stop the sun blanking it out, and we used incredible new LED technology, and this will probably burn your eyes out. It's my initials. This was given to me as a leaving present by the group when I left that part of the business. But sometime in the future, perhaps I'll explain how that worked. But we went from 500,000 in the UK market to 8 million, 80% of the UK market overnight. It was world-leading technology. From there, I moved to aerospace, Rolls-Royce, and then on into the marine and nuclear divisions, where I led the implementation of new office complexes and ultimately finished my career working on engineering skills. And I can represent this in this rather busy slide. I apologise for that, so don't look at the detail. But if you look at the left, the ovals, the yellow ovals at the left, that shows the stages in my career. So the first part was getting the technical groundwork, understanding different types of technology. As time went on, I became more customer facing, overseas work, project management came in, and gradually over time becoming more of a leader, owning strategy, and looking then in the later stages towards the top about investing for the future and then people for the future. And then when I retired, that was the time for giving back, so developing people to take over from me for the future, and that's what I feel I'm doing now. The yellow ovals in the middle are all about the sort of courses I took, and you'll notice a lot of it was mid-career. So I did an MBA, kindly Rolls-Royce supported me, but not until mid-career when I was ready. I got that solid engineering base and project management. Then was the time to build these extra strategic skills. And finally, on the right, there's the levels of professionalism in the letters after my name, if you like. So in parallel, being as an associate member of the Institution of Mechanical Engineers, becoming chartered, member of the Chartered Management Institute, taking an interest in the profession as a trustee, and gradually moving all the way up to where I am today. So that's the experience. But to answer the question, which I still haven't done, where did I use those skills? Well, here we are. A very, very busy slide. Please don't look at the detail, but just to say that I used some of those things I learnt at university immediately. Some I didn't use for 20 years. And no, I didn't remember them, but I remembered how, and I was able to look at the books or the texts to find out how to use them and apply them. Some I never used, and then in the latter part of my career, some new things that I never learned at university, so contract law, finance, personnel development, strategy, HR principles, how to work with government body, recruitment, and governance and auditing and risk appetite, all those things. So the message there is we're giving you the basics, the tools, and then you will learn and develop. And this applies not just to science and engineering, but to every degree, every life, every career. So if you want to get on, here are my rules. You look up, you look out, and you look far, and you stand out from the crowd. And certain behaviours, here are the behaviours which I've found, I've observed and tried to do. And the red ones particularly are the ones that you will need, especially if you're going to lead people and lead businesses. All of them are very important, but these are the sort of behaviours that will take you on. Communicating what you want to say, what you want to get across, business plans. Courage to stand alone is absolutely critical. You can be the quiet one in the room, but it's so important if you're the one in the room who stands up and says, if we do that, it will not be safe, or I think there's a better way of doing this. You might be the only person saying it. If you've got the courage to say that, you can lead. Learn from failure. Professionally behave well. Build relationships and customer focus. Remember who your customers are inside and outside your organisation, and they are the most important people. Develop emotional intelligence and have that enterprising mindset to develop. Now, those are my perceptions and views and what I've learned from organisations I've worked for. There's a very expensive committee, much more highly paid than me, have come up with this, the Entrecom framework, the entrepreneurship competence. And if you look at that quickly, you'll notice that they're almost the same ones as I've put down. You can find that on the internet. And you may say, well, what about the future? Well, here are some skills which are in very high demand and will develop over time. Just as a background, when I started university, the only computer we had occupied a whole room and had less computing power than any phone has today. And we had to book sessions to use it. We didn't know what it did, but it was very clever and came up with answers. So there was no such thing as computational fluid dynamics or even CAD at the time I started. So I had to learn these things as I went along. But today, there are huge numbers of adverts for battery technology, for example. Shell and BP, the big players, are wanting battery technologists. They're wanting additive manufacturing experts. They're not coming out of university fully fledged. Stem cell manufacturing, fantastic. I was hearing just the other day that if you take tree stem cells, you can 3D print them now to make furniture, for example, and rather than going to IKEA and ordering something and having to wait 50 years while it develops, they can print out, not IKEA, but in theory, they could print out an oak table just in a matter of hours. So limited only by your imagination. Nuclear energy, I'll show you what's coming. But all of this is based on a sound fundamental science and engineering core, and that's what we develop in this university. Now, let's go look more forward indeed, and here are some examples of, for example, HS2 here, shown in this top diagram, is similar to the Romans coming to Britain when they remapped the network of communication lines in Britain to suit their travel needs with Roman roads, which some are still here today. That's what HS2 is doing. It's remapping Britain, and for that it's a build for hundreds of years, not just for the next 40. That will last and remap Britain to the future. It's not about high speed, it's a new network of connections. And here we have Hinkley C nuclear power station, partly to help with huge electrical demand which will happen with green power, whether it's heat pumps or whether it's for electric cars that are coming sooner than we thought. And the importance of these is it's where the jobs will be. So there's an expression which sometimes applies to crime, sometimes to politics, sometimes to fraud, but that expression is follow the money. And in this occasion, I mean follow the money and you'll find where the jobs go. So in HS2, for example, there are 29 big contractors, each of which has money contracts to them between 10 million and 3 billion pounds, and 93 at the next level down up to 250 million. Now, wherever that money's going, jobs will surely follow. So if you want to find out where jobs are, all the data on the contractors is on their websites. And the same with Hinkley C. There are 163 contractors with contracts value up to greater than £1 billion. There will be masses of jobs for those. And a bit closer to here, Rolls-Royce has recently been working on replacements for Sizewell B, for example, which I worked on, 1995. That was live in 1995. It produces 1.2 gigawatts of power. It cost in round about, I think it was 2.7 billion at the time, but in today's money, that's nearer probably 15 billion to build one. And that is too much for even individual contractors to pick up. So countries have to back that. So the affordability, the initial investment, we need to find a better way. And this is what Rolls-Royce have come up with. On the bottom right is the small modular reactor, which are estimated will cost about 2.5 billion each. They will generate about 500 megawatts of power, which is enough to power, say, a city like Sheffield. This new development could create 6,000 jobs, and 16 of these will be needed in the UK alone. Cost around about 2.5 billion each of them, so much more affordable in risk terms for companies, and huge worldwide opportunities for export. I think at one stage there were trillions of money equivalent in new investment available for nuclear to cope with green demand. And right next to the Kedleston Road site, we have the A38 improvements, which will reduce emissions and cause huge cost savings in the delayed traffic and fuel and fumes that are developed currently to improve the junctions. Around 200 to 250 million, which again is huge local construction jobs in the time. I know there'll be disruption, but jobs will be there. And if we're talking really big jobs in the area, then this is potentially one of the biggest, the East Midlands proposed Freeport, providing green jobs, making logistics centres, and linked up as part of the HS2 new spine going through it, a bit like the Romans did. It will take over the site of Ratcliffe-on-Soar coal-fired power station when that closes in 2025. Huge opportunities, round about 60,000 new jobs potentially. So there are some takeaways from this. Here they are. SMEs are key to future UK growth. They need skilled, innovative, enterprising people. There's an opportunity for much greater interaction with these small and medium companies, the 264,000 that I talked about. And of course, you are exactly the sort of people they need. I want to finish this on this presentation, this lecture, with some thoughts and reflections to all students and staff, both my own and from other people. So here are some aspirations, and if there's anybody watching from the law school, either students or staff, please don't sue me for the first one. It wasn't me that said it. It was Richard Lamb, the former governor of Colorado in the States, still alive today, and what he said was, all we know about the new economic world tells us that nations which train engineers will prevail over those which train lawyers. No nation has ever sued its way to greatness. As I say, that wasn't me, but interesting specification. Now I have some 21st century heroes of the creative sector, and here are two of them alone. On the one side we have Professor Sarah Gilbert, who has been very focused in her whole career in vaccinology, and she's come to the fore. It's a specialism, she's focused on that. Unlike my career, which was very general and moving from different fields, there she was. She's now specialised, and she was the key developer of the Oxford University AstraZeneca jab for COVID-19, which I was very pleased to have just recently. So fantastic hero, she's dedicated to that profession. And then on the other side, we have the dreamer, Elon Musk, who's made his money in other fields, but has brought about the Tesla cars and, of course, the space race today going potentially to Mars. And to see that again, when I grew up with the Apollo 11 and before spaceships taking us to the moon, to see him potentially going to Mars, I can't wait. I'm very excited by that possibility. But he dreams and he produces. And then some perhaps more relatable ones. down-to-earth people. Katherine Johnson, top left, fantastic. The human computer, as they were described at the time, and you may have seen the film Hidden Figures. She was a real role model. She developed the programs, did the calculations to enable our first flights into space and to the moon. So she effectively beat the IBM computers of the time. I do encourage you to see that film if you haven't. The virtual reality that we can see at the bottom left. Top right, we have Roma Agrawal, who was a designer of the foundations of the Shard building in London, and that's no mean feat given that London is built on clay, so they're quite difficult foundations. And bottom right, we have Steve Jobs, who's brought us the iPhone and all those other inventions around the world. Here are some thoughts from me which go with these. I think these are very important. So first one is, every experience you have in life, even things that are bad at the time or seem bad at the time, are part of your cumulative development. So looking back as I've done at the end of my career, everything, it shapes you and who you are. Sometimes do reinvent the wheel. Mr. Dyson, Sir James Dyson, has made a very large amount of money and had a very successful career by reinventing hair dryers, vacuum cleaners and many other products. Never ever stop learning. I continue to learn today, and I'm sure you will throughout your careers. Develop people, treat them as you'd like to be treated yourself, and take time for everyone and treat them as equals. Very importantly, set aside time for your health and fitness, and I've done that throughout, and for my family. Make time for people, no matter how busy you are, it matters. Key is, if you want to go far, understand money and finance at all levels, both personal and how it shapes business, and what happens when businesses run out of cash. And this is perhaps one of the most important that really came to me when I was mid-career, which is open your mind to different. So think of different music. So I love music. I listen to anything from Dua Lipa to metal to classics to rock to electronica to swing to jazz. I love it all. It brings a different way of thinking. Open your mind to history, read literature. When I was about 40, I set myself a target of seeing every Shakespeare play before I die. Well, I'm about the third way through, so I hope I'll live a bit longer yet. Be careful and listen to the environments, think of the environment, think of people and nature, and be close to nature, go out walking, and read widely, so read classics as well as thrillers. Read Shakespeare, if you will. And most importantly, don't say we can't, but imagine how we can. Now, the third question I set you was, which philosopher am I going to quote towards the end? Well, I'm afraid it's another bearded gent. It's another black and white picture, but he's a bit more recent. And I'm talking about a political philosopher this time rather than a scientific one. And this chap said, philosophers have only interpreted the world in various ways, but the real task is to change it. None other than our friend Karl Marx, and he was talking politics there. But I interpret that in the way of science and engineering, or indeed many of the other areas of the university. So how will you, as a scientist or an engineer, change the world? Thank you very much, and I'm open to any questions.
Patrick, thank you very much indeed for that presentation and your reflections there. Very insightful, and there's been some questions come in, and I've got some questions as well actually, so I'm going to take the chair's liberty and frame those on behalf of colleagues who've sent some questions in prior to today, but also some that have come through. So one of the things that'd be interesting to get your reflections on, Patrick, from your experiences in business and engineering companies, the difference between working in an SME and then one of the large corporates. Obviously you spent quite a lot of time in Rolls-Royce, but you obviously have also highlighted some of the smaller companies that you've worked in at various times in your career, and actually probably some of the work you're doing on behalf of the college and the university in terms of engaging with SMEs within the region. But what's some of your reflections in terms of that difference between working in SMEs and then the large corporates?
Yeah, thank you. That's a very good question, and one I'm very delighted to explain. Larger organisations sometimes can be very fast, because they have to be, but by their very nature they can be slow to change. Can be, not all are. An SME often has to live hand to mouth. They have to live close to the customer, they have to move with the needs, and cash is important in all sizes of business. But SMEs often have to balance that cash flow with investing in the short term very quickly. And one of the great things about SMEs is you, perhaps particularly taking the example of rotor wing fans, which I worked with in the 1980s, was that one day I could be in the office with my design team. I would make their coffee. I would do the photocopying for myself. There was nobody admin to do that for you. But the next day I would be out with the sales manager meeting customers. The very next day I was talking to the managing director, the chief executive, looking at where the business was going next. And the day after I would be back making the tea again. So you see all sides of business, and I would be out on the shop floor, perhaps next hour between between designing something. So it's very close. You learn all aspects of business. You see the customer face to face. I spent a lot of time on site, and it's that speed of organisation and seeing all aspects of it. So it's a great learning opportunity, and there are so many of them working at high-tech ends, as I've tried to explain. In a large company, there are only small numbers of large companies, and lots of people know of them, so they'll apply to the large companies. So the chances are, if you're applying for a job there, you might be the chances of getting a job are maybe 1 in 1,000. With a small company, it may be 1 in 2, or even they may not have any applicants. So the chances of getting work and getting experience are great. And the final point I'd make is many of the small and medium enterprises are in the supply chains of the larger companies, and you can get noticed. And that's how I moved to SKF from the telescopes. They saw me and thought he'd be good for coming and selling factory automation equipment.
Okay, that's really interesting, thank you. One of the things I'll raise, I mean, you spent quite a bit of time working within the nuclear sector. Just what are your reflections? Because obviously there are some societal sensitivities when we're talking about nuclear energy, and you know, it is the case that Rolls-Royce are looking at their small modular reactors. I think it is part of the government's 10-point plan for clean energy and clean growth when they're talking about reducing of the carbon loading associated to our future energy barns, which are going to be huge and vast. And I think that's where a lot of science and engineering related innovations are coming into, about how we conserve and how we produce energy in neutral ways. Just what are your thoughts and experience of kind of working in that nuclear sector, and how would you put people's minds at ease in terms of that societal sensitivities around future energy systems coming from nuclear sources?
Yeah, I'm very proud to have worked on Sizewell B, absolutely proud. It's delivered clean, green energy for the last, 1995 to 2021, I can't do the maths, 26 years so far. And yeah, very proud of it. I would say, reassure anybody that the design criteria for nuclear power stations are everything's to 1 chance in 10 to the 7th, something like that, of any failure. You design for that, and then you look at the aspects of how one failure could contribute to another failure. In terms of what goes up the chimney, if you like, less radiation is emitted from a nuclear station than from, e.g., a coal-fired station or many other stations. And actually, there is some natural radiation in coal and other fossil fuels that goes up the chimney. And if it were monitored in the same way as a nuclear station, then they'd be shut down straight away. And that's not to say a coal-fired station is unsafe. It's just reflecting the background levels of radiation. Great care is taken in design to make sure there are no failures. Say it's clean, green, very low CO2. The long-term storage of the used fuels is continually being looked at for improvements in the way that's dealt with. But No, I'm very proud of it, and it's key to the base load of the UK and around the world. And after all, it's an energy source that is sitting in the ground, gradually degrading, as you know, with radioactive decay. And if we don't use it, it's not going to be there at some stage in the future. As long as it's safely dealt with and it's always being improved, then I'm very much in favour of it.
And I think it's one of those examples, isn't it, in terms of the new technologies, those new energy systems will actually drive the behaviours to improve our ability to deal with some of those spent wastes that come out of nuclear fusion reactions. And I think that's something that, again, if we look back 20, 30, 40 years ago, we were still learning some of these skills and experiences. We've looked forward another 20, 30 years, we'll be much better at dealing. So I think that's some of that development and enhancement, isn't it, in terms of much of your career has been around how do you improve and find these new solutions.
And that's without even looking at thorium reactors, which potentially the byproducts of those are even less of concern. So,
yeah. One of the questions that's come in is around the notion of a hyperloop concept. And someone's asked the question in terms of, you know, if HS2 is for the future, is there some sense in considering the options around the use of a hyperloop, and could that be a feasible alternative instead of a HS2 system?
Gosh, I'm not a hyperloop expert. I suppose the good thing about HS2 is it's conventional in most senses, although very high tech. My understanding was the costs could be quite high, because tunnelling costs are very high, of course, if you're putting the loops, the tubes underground. Tunnelling costs are extremely high. I think there are also issues about how do you describe it? The movement of the ground over extremely long distances, and you know, I think it was proposed in the LA to San Francisco area was one of the proposals. Now that's a high earthquake area. I don't know. Travelling in a vacuum, travelling at high speeds, I suppose again it's all to do with safety and what would be the mechanisms in case of failure of, say, the support mechanisms, whether it's electromagnetic or otherwise, and vacuum failure. So I don't know. I'm not an expert. I haven't even read really on Hyperloop, but it's exciting. And Elon Musk is the man who says, how can we, rather than we can't. So I'm all in favour of that.
Indeed. Thank you for that. One of the things that your other inventions have been around the motorway signs. Have you seen much change in those since you patented the designs originally?
Yes, yes, we have, because what happened at the time was I don't know if you can see these again. If I bring this up,
yeah,
I'll bring it very close to the screen. You can see there's a sort of shaped device. Behind those, or enclosed in those, is an LED. And at the time we developed this, the mid-1990s, LEDs weren't particularly bright, and it was quite difficult to get the right colours. And so one particular fact about those was that the LEDs, any LED in its normal shape, which is a sort of cylinder with a spherical end, if you've seen them, I haven't got one just to hand, but they lose something like 80% of their light out the sides or backwards. So that's not fed into the into the driver's eye, if you like, in this application. Using that little optical shaping device, we were able to recover much more of the light through total internal reflection, and then shape the beam so that pretty well all of the light was shaped and focused into the plus or minus 7 degrees vertically and horizontally that the driver would see on the motorway, rather than illuminating squirrels in the trees or going back into the sign enclosure. And so that was what we did, plus the shaping of the shuttering here to stop the sun bleaching out the display. So that part's remained. But of course, what's happened since then is improvements in the base LED technology means the basic LED itself has become so much brighter and more efficient. And so the need for those has perhaps moved on, but they certainly were market leading for about 15 to 20 years. But the company still exists. It's now outside the Rolls-Royce group, but it's developed the technology and it's used in railway signalling as well.
it's amazing to to be working alongside, and obviously to have met you in terms of the individual who passed into the technology from it, because I think we all benefit from that almost on a daily basis. So thank you for your work on that. And I think, to me, that's also an example where there's that importance, and you highlighted it in some of your talk, around understanding from an engineering perspective the interface of different types of engineering, rather than just the mechanical or just the electronic or just the production side of it, and therefore there's that hybridization across the piece in terms of the different ways in which people are looking at those different ways of engineering. So again, just briefly in terms of your reflections on that, because I've got one final question that's also coming as well, which I think could be a good question to end on. But how do you see that experience across those different types of areas of engineering, and the advice you perhaps give to students to look across that?
I think it was the open-mindedness of it, being prepared to use the base tools that I learnt at university, and to pick them up and use them, and not limit yourself to one particular field. One of the things I noticed very early on, I went for an interview at a company which was in the aerospace fields back when I was leaving university, and I thought, aerospace must be the most exciting part of the whole world. And I looked at the car industry as well. But actually, the role I would have had would have been quite boring and uninteresting. Whereas when I went to the electrical switchgear company, Railrolls, they had some incredibly difficult mechanical and electrical engineering problems to solve that involved everything from how do you make a switch contacts and separate them very quickly, and put out the little arc that sets up. Is if you open a gap when electric current's flowing, then you end up with an arc that burns, and so you've got to make that break very quickly. And how do you extinguish that arc? And it's those sort of challenges that make technology interesting. So you never know where the interesting parts come in. I think what I've also noticed is there are three types of engineers and scientists: those that become very detailed, deep specialists in one particular field, might be absolute experts in nuclear reactor core design. At the other extreme, there are people who are generalists like myself, who take a great interest in strategic management and developing people. There are other people who really thoroughly enjoy delivering projects, so they take a whole project from the beginning to the end, and they develop those skills, so delivering the whole of HS2 on time, to budget, and as to the right quality, which is almost an impossibility. So it's be as broad as you want. There are so many opportunities. That's the great thing, and this applies as much to science as to engineering. You can be a specialist, a generalist, a project manager, and other mixtures in between.
Great, thank you. And a final question that one of our listeners has posed, which was, in terms of your own reflections, you kind of posed the question as to how would you change the world. If we spin that onto yourself, Patrick, how would you change the world?
Oh, how would I actually change the world, or how have I changed the world?
How would you like to see it change? What would you like to change about it, and probably the influence you've had on that?
Right, gosh. Well, what I have changed is I've left some marks in telescopes and road signs for the moment, but they're arguably temporary. They're 40 years. How would I like to change it? Gosh, that is a difficult one. I just see the opportunity to make the world a friendlier, cleaner, greener place, to use science for all the best things, but to always think of people and how what you do might affect them, both in a health way and for the greater good, because that's what engineers and scientists can do. They can take ideas and create real things that make the world a better place. That's a very general answer, but I don't know. I think we've got fantastic examples in the current state with those scientists and engineers who've developed the solution to a COVID vaccine, and more importantly, how you can do that in quantity and deliver to people at pace. That's phenomenal achievement. Let's mirror that in other ways.
Indeed. Patrick, thank you very much indeed, and my deepest appreciation for your lecture today as part of our student lecture series, and also the work that you continue to do on behalf of the college and the university around entrepreneurialism within the curriculum and how we can support students in terms of their employability post their degrees. And also the work that you contribute to at a national level in terms of your insights work with the various science councils, as well as the Science Council, and therefore your contribution to the continued development of our subject areas. It's a huge thank you, and we're very grateful for the work that you continue to do in that. Even in your retired years, you sound probably as busy as you were as when you're employed. So thank you very much indeed for your contributions, both to the university but also nationally as well.
Well, it only depends if I get good at golf, then you might see it of me when we're allowed to.
Well, all the very best with that as well.
Thank you.
That concludes our presentation today in our student lecture series from the College of Science and Engineering, with Patrick Kniveton as being our guest speaker today. I hope you've enjoyed it certainly as much as I have, and those who've engaged with some of our questions and dialogue. Obviously, we have further lectures taking place over the coming weeks and months, so please do continue to engage and participate in our student lecture series. And I think one of the reflections I had from what Patrick was saying today is do open your minds to different areas. And certainly as you go through, keep a breadth of what is taking place in different subject areas, in different disciplines across our university colleges, because those skills will become increasingly important as you go into your employment after your degree. So once again, sincere thank you, Patrick. Thank you to colleagues for listening to today's lecture, and I draw it to a close. Thank you.
Thank you.